All right, let's take a look at the last thing on section 1.4. It seems like it's taken us a week to do this one section. But that's okay, because all three of these things are really important. It's important here in geometry, but it's also important in algebra. Okay, when you get up to algebra 2, you're gonna hope you remember this stuff, because you're gonna do a lot of this stuff in algebra 2. All right, that would be next year. Okay. Is there gonna be anybody left? All right. What's that? Oh, Zion, you're killing me. I'm ready to teach, and I got all these people leaving, and you're gonna leave. Hurry up. Oh, that's right. Trey had his out. I said he could go. My goodness. Everybody's deserting me here. All right. As soon as he comes back, you can go. All right. Let's talk about the word slope. Basically, the word slope means how steep something is. All right. So if I drew a line, let's make it so it shows up. There we go. All right, so if I drew a line like this, it's got a certain steepness, all right? So if I was, as you know, I used to do a little hiking, right? There's my hiking poles right there. That's me. Here's my backpack, all right? And so when I'm going up a hill, if I'm going to go up on top of a mountain, sometimes I go up really, really steep hills, all right? So sometimes they're steeper than others, depending on how high the mountain is. So for instance, if I took this, let me see if I can move this around, okay? Look, that one right there is a lot steeper, would you agree, than the first one that we had right there, all right? And you could also have lines that maybe go in the other direction, like this. All right, so if this was me, and let's do this. Let's get rid of this. All right. And let's tilt it a little bit so I'm going down. So look at this. Now, this is what I kind of enjoyed. Actually, to tell you the truth, sometimes going down the hills is pretty tough, because it's kind of tough on your knees. If you're going down a really, really steep hill, you ever see hikers with the poles, right? When I first started hiking, just day hikes and stuff, I would see people with poles, and I was like, why do they need a pole? Especially around Lum's Pond. Lum's Pond's like super flat. Like, you know, I kind of, in my head, I wouldn't in front of them, but I kind of, in my head, kind of make fun of them because they had these poles. But I tell you what, when I started doing some real hiking and some backpacking, and I went up these really, really steep mountains and went down the steep mountains, those poles are so helpful. It's kind of like walking up the steps and you have a handrail. You ever do that? You get tired, you're walking up the steps, what do? You kind of like pull yourself up on the handrail. Would you agree? That's kind of what those poles do when you're hiking, okay? It's like you're pulling yourself up, not just with your legs, but you're using your arms too. But going downhill, it's really, really helpful because it helps your knees. Instead of just pouncing down the hill, putting all that pressure on your knees, you're putting a lot of the pressure on the poles, right? And you kind of like hold on to the poles as you're going downhill. So those poles are actually very, very helpful. But what I'm talking about here is I'm talking about going down the hill and going up the hill. So let's use this in math. If we were going, I'll tell you what, I'll just get rid of this. If I was going up the hill like this, we say that we have a positive slope. This is positive. I'm talking about going from left to right, okay? If I'm going left to right, this is going what? Up the hill. Do you agree? So this would be a positive what? Slope. All right? Okay? And then what if I was going this way? Correct. Okay, come on, if I could click off of there. I'm starting to regret my choice in changing to this graphics tablet because not as good as I thought it was going to be. All right, so that's a negative slope. Why? Because you're going down. You're going what? You're going down, okay? So again, from left to right. Left to right, if it's going in this direction, that's a positive slope. Left to right, if it's going down, that's a negative slope, okay? Now, some slopes are steeper than other slopes. We already talked about that, but I'm going to do it one more time. All right, so watch. You could have a slope. We'll make them both negative. That's just barely goes up. You see that? Or you could have a slope that goes really, really steep. Okay? This is how we define a slope. This is how we figure out what the slope is, okay? How steep it is, right? You can look at it and say, yeah, that's a lot steeper than that one. But how do we determine? Well, glad you asked. What we do is we take 2 points. They don't have to be endpoints because these could be lines. These lines could keep going forever and ever, okay? But I'm just going to do that right there. Just going to take this little point right there. Now, what we're going to do is we are going to compare something. We're going to compare, watch, if I took this like this, and then if I went from here to here. Okay, do you see that? I went straight across, I went straight up and down, all right? Look at the straight across. That's a lot bigger than the up and down, isn't it? Or let's look at the other way. The up and down is a lot smaller than the distance going across, correct? So if the up and down is a lot smaller, it's going to be a lot less steep of a slope, okay? What if we did the same thing here? What if I compared that to this? And let me just make that go to there. Yeah, we do have a triangle. I heard that. All right. But look at this. Going across left and right is a lot smaller than going up and down here. Would you agree? So if the up and down is a lot bigger, then it's going to be a steeper slope. If the up and down is a lot smaller, then it's going to be a less steep slope. Agreed? All right. So what we're going to do is we're going to talk about this up and down and this one going across. This one going up and down, we call it the rise. I'll do it here because it's so small here, it's kind of hard to fit it in there. All right, this is the rise. Zion, you already said it earlier, so what's this one going across? It's the run, okay? So that the way that we determine how steep something is we compare the rise to the run. Everybody hear me on that? Okay, that's what we're comparing. We're comparing how far up do you go compared to how far across you go. All right, the rise goes up and down, perfectly up and down, vertically. Okay, the run goes horizontally. All right, so we compare the rise over the run. So we have a little formula. This is the formula. Well, we're going to talk about it in a second, but the formula is rise over run. And I'm sure that you've heard that in Algebra 1. Can I believe that or not? Did you hear rise over run in Algebra 1? Yeah, absolutely. It's a very popular thing. Every single Algebra 1 class teaches rise over run, okay? That's the slope. It's how steep that line is, okay? What I'm going to do now is this. Let's draw another slope. And I'm going to put some x1 and y1s in there. Remember how we did that for the distance? And we did that for the midpoint? We're going to do the same thing with the slope, all right? So watch. So let's say that's my slope right there. And I'm going to put a rise and a run. I'm actually going to put them in different colors. Put that there. And let's make this a different color. Put that there. Let's try this again. Let me get it right there. All right, and let me just move this over just so it connects. There we go. Everybody with me? All right. So what I'm going to do, let's do some green. Add some color to this. What I'm going to do is I'm going to call this my first point. I'm going to call this the second point. So pretend this is on an x and y coordinate, all right? So what do you think I'm going to call that first point? X what? 1, what? No? It's an x and a y, okay? It's not an x and an x, it's an x and a y. So if that's my first point, I'm calling it x1, y1. What do you think I'm going to call this point right up here? x2, y2. Oops, put a 1, didn't I? x2, y2. Now, I don't know if you can figure this out or not, but let's figure out where this point is. Like, how far over did you go to get to this? Well, you went the same distance that you went for this one, didn't you? This was x2, wasn't it? So what's this going to be? That's going to be x2. How far down did we go? Well, we went down to y1. I'm not going to, if you don't understand what we just did right there, it's not that big of a deal, all right? But that point right there is going to be x2, y1, right? Why is that? Because it's right under this x2. Do you see it? See that? If that's x2, this point right here has to be at x2. Or if we went over, I should say that. Yeah, we went over x2. Well, we go over x2 to get to that. Now, where is the y point of this? It's the same y point as this one. That's why it's a y1. Again, don't worry about that too much. So let's talk about the rise and the run. This was the rise, correct? And this was the run. So how far is it from here to here? We're talking rise, talking up and down. So I'm looking at my y's. This point was y2. This point is what? y1. So how do I find the rise? What is it? It's y2 minus y1. For instance, what if this point right here was at 5 and this point down here was at 2? What is the distance between 5 and 2? It's 3. And how did you get that? You subtracted. Would you agree? So the rise is y2 minus y1. So what do you think the run is? No, that's right. So it's from here to here. So if I know that point, I don't know, let's say this was 7 right here and this was 3. What would that distance be? No, just with the 7 and the 3. Okay, don't think ahead. Just think right here. If this point was 7, this point was 3, how long is that yellow line? It would be 4. What'd you do? What math did you do? Subtracted, didn't you? You went this one minus this one. I put a 1 right there. That should have been a 2. My bad. No, that's correct. Nope, I'm right. So what are we going to do? We're going to subtract the x's. So what's the x here? It's x2, and this is x1. And again, if you don't understand this, it's fine. What I'm going to show you at the very end is what I really want you to understand. Okay, but if you get this, you get it. So remember what we said the slope was. The slope was the what? The rise over the what? The run. What did we say the rise was equal to? y2 minus y1. This is what I want you to get right here. Over the run. What did we say the run was equal to? x2 minus x1. Okay? Now, don't worry about how he got those. Okay, I'm not that concerned about it with you guys. All right? I just want you to see that the rise over the run is the distance of the rise, which is y2 minus y1, over the distance of the run, which is x2 minus x1. So that's your slope right there. So let's write it. I'll keep that right there. Let's write it nice and neat and plain so that you can see it. Oh, by the way, I didn't say this. For some reason, they give a letter to represent the slope. What do you think it would be for slope? If it's slope, you'd think it would be S, wouldn't you? Okay, it seems like that would make sense. It's not, though. They use another letter. And to tell you the truth, I looked it up. I looked it up to see why it's this letter, and nobody really knows where it came from. People have ideas, but they're not 100% sure. Nobody can agree 100% why they came up with this letter. So if you ask me, Mr. Hamrick, why'd you use that letter? It's so weird. It has nothing to do with slope, with S. All right, you'd think it'd be S. But they use the letter M. The letter M represents the slope. The way I like to remember we talked about, I like everybody listening? Sincere? Come on now. Donnell. I'm still talking. I'm not done. You act like I finished. So they use an M. Again, if you look it up, people will say, well, it's because of this, because of that. I like to think of it as, I think some people said it might come from like a Latin word that kind of means mountain, right? You go up a slope, it's a mountain. That's how I like to think of it. It may not be why it's M, but that's how I like to think of it. So think of M as a what? As a mountain, as a slope up a mountain, okay? Think of me hiking up a big old mountain, all right? And M is the slope. So here's what we write. The slope is just a fraction. It's a comparison to the rise over the run. What is the rise? Y2 minus Y1. What's the run? X2 minus X1. And that right there is your slope formula. Okay? That's something you have to memorize. You got to memorize the distance formula. You got to memorize the midpoint formula. And you have to memorize this. It's not really a formula. It's kind of like a definition. But you got to memorize this for slope. All right? It's very easy to do. Okay? Let me give you an example. And I'll give you a couple examples. Let's do this. Here's an example. EX, for example. All right, so what if it said find the slope between these 2 points, and they give you 2 points. They give you 0, 2, and they give you 4, negative 1. This looks just like one of the problems where it says find the distance and find the midpoint, doesn't it? Doesn't it look just like it? They give you 2 points, but you're finding something else. You're not finding the midpoint. You're not finding the distance. You're finding the slope between those 2 lines. How steep is that line? What's that? Yeah, absolutely. Anything I write up here, you're going to write down. Thought we've had that discussion. All right, so find the slope. It's M equals, watch, here's what I do. I put a bar, right? And I've already got it written up here, right? You've got it in your notes already. But again, what would I do to memorize what the slope is? I'd write it down every single time, okay? But we're running out of time right now, so I'm just going to put the numbers in. Y2 minus Y1. So I subtract the Y's from each other, all right? This is a Y, and this is a Y. So I'm going to subtract them. Let me tell you this. It actually does not matter what order you subtract them. But, listen, as long as you subtract the X's in the same exact order, okay? So I could go Y2 minus Y1 over what? X2 minus X1. Or if I wanted to, I could say Y1 minus Y2 over what? X1 minus X2. All right, as long as you subtract them in the same order. But let's do the 2 minus the 1 since that's the way we did it. So what's my Y2? It's negative 1. Minus what? The Y1. What's the Y1? It's 2. All right, let's do the same thing with the X's. These are my X's. That's my second X, and this is my first X. So I'm going to take the second one, which is 4, minus what? 0. And then we just simplify it, and that's it. Might be the easiest of the three, tell you the truth. All right, negative 1 minus 2, negative 3 over 4 minus 0 is 4, and that is the slope of the line that connects these 2 points together. Okay, that's the slope. That's how steep it is. It also is negative. That tells you what? That it's going down like that, okay? That's what that negative tells you. And it says, for every 3 you go up and down, you go what? 4 across. That's what that's telling you. It tells you something very specific about that line, okay? Everybody see that? For every 3 you go up and down, you go what? 4 across. Let's do one more. We'll be done. What if I have this? 1, negative 4. I'll let you do this one. Should only take you a minute, less than a minute. And 3, 2. All right, there it is. That's 1, negative 4, and 3, 2. And I want you to find the slope. I'm going to put M, because we're going to use that M quite often a little bit later, okay? So know that slope, the letter M represents the slope. Anybody get an answer yet? What'd you get? Okay, and you're going to leave it like that? Yeah, absolutely. Okay, if you get a fraction, make sure you simplify it. Now, do not do this. Don't change it into a mixed number, okay? Like, you wouldn't write a slope as 2.5. Everybody got that? Or 1.5, or whatever it is, okay? So let's do it. Let's subtract the y's from each other. So it's 2 minus what? -4, and then 3 minus 1. All right? It's that easy. Just make sure you do the y's on top. Some people forget and they put the x's on top. Why do you think they would put the x on top? Why do you think they would make that mistake? Well, because x is first, right? And sometimes we like to do the x's first. But remember, it's rise over run. Rise is the y direction, up and down. Okay, x is the horizontal direction, the one that goes across. So make sure that you do the rise over the run. So what's this? Minus minus is 6, and then 3 minus 1 is 2. Are we going to leave it like that? No, we're going to write it as 3. All right, and you just leave it like that. If you wanted to put 3 over 1, because there's your rise and there's your run, that's fine too. But I would leave it like that. I would just make it 3. And that's the slope. That means it does what? It means it goes up like this, and for every 3 you go up, you go over what? 1. All right? So that's a fairly steep slope, isn't it? Okay, your homework is numbers 13 to 22 on 3-4. It's the same section you've been working on, but you're doing 13 to 22. We're going to call it section 3-4C, all right? It's the same section, and that's page 133. So that's your homework. Shouldn't be very hard. Should be pretty simple, okay? And there you go.